Hi, so today Anna Maria, Kavya, and I will be discussing the future of telecommunication in Africa. So, for our presentation today, we will go over the background, the current status of telecommunications, as well as its infrastructure within Africa, the current steps for development, and how they are looking to set future goals. And following that, we will look at providing recommendations on what should be their next steps.
So, we are students in a telecommunications class, and we know the importance of telecommunications. We've done some research for developing countries, and these countries lack internet access, which many consider to be a human right. We'll focus our research on countries in Africa and relate the content to what we've learned in class. Developing countries are at stake because a lack of connectivity makes advancement difficult. So, Finland and Spain have recently declared high speed internet access to be a legal right. And in July 2016, the UN declared the importance of applying a comprehensive human rights based approach when providing and expanding access to the internet and for the internet to be open, accessible, and nurtured. Facebook CEO Mark Zuckerberg says, "Today we connect more than 1.15 billion people each month, but as we started thinking about connecting the next 5 billion, we realized something important. The vast majority of people in the world don't have access to the internet. Connecting the world is one of the greatest challenges of our generation. This is just one small step toward achieving that goal. I'm excited to work together to make this a reality."
So, one of the main reasons we want to focus on Africa is due to the current digital divide. And the definition for digital divide is the gap between individuals or households or just geographic areas where the different socioeconomic levels regards to opportunities to access information and communicate with others using technologies varies between them. So, for example, if we look at the graph here, within the developed world, we see that a larger percentage have access to the internet in comparison to, I say, the global median and the developing world, which is far below. So within many countries, we see that about 65% of households have internet access, given that Korea, Netherlands, Finland, and Sweden have about 80% of their households having access. As you can see at the bottom of this chart here, many of the sub-Saharan African countries are at the very bottom, starting with South Africa, Kenya, and all the way down to the very last, which is Ethiopia, which currently has only 8% of their population having access to the internet. So if we look at this current graph, we can see that there's a strong correlation between the GDP of a country and the internet access within the country itself. For example, at the very top right of this graph, we see that countries like Australia, Canada, UK have very advanced economies, and therefore many of them have access to the internet. Whereas here circled in the green, we see that 9 of the green points are all sub-Saharan African countries, and they are all way below at about 40 or less percent of access to the internet.
So we can see in the graph that only 34% of households in developing countries don't have access to the internet. And further, we can see that Africa has the lowest internet penetration rate, which is why we chose to focus on African countries for our research.
The progress in a number of developing countries which have displayed significant improvements in their ICT Development Index, which is also known as their IDI values, and rankings that have occurred since 2010 is particularly encouraging. The more dynamic countries have had substantial increases in mobile broadband penetration, household ICT access, and international internet bandwidth, among other features.
So the current status in East Africa is that it was the last major area on Earth to have access to fiber optic broadband internet access. So this made them have to rely on using satellites for internet access, which typically is a lot slower and more costly than using broadband. Since then, the region has connected to 3 submarine fiber optic broadband cables, which in return has increased the speed of the internet as well as decreased the cost. Local exchange points, also known as IXPs, have been placed throughout Africa, and now there are about 20 or so of them, and this allows the round-trip time delay to be decreased given that these terrestrial links are placed within the area. But West Africa continues to lack in local peering. So in the image here we see that all these submarine cables have been implemented, and they connect Africa to parts of America as well as Asia as well as Europe. And this has allowed them to have faster internet connections since 2014. So given that all these submarines, fiber optic, and terrestrial links have been implemented, the RTT, round trip latency delay, has decreased significantly given that they don't rely so much on satellites. The area that saw the most improvement was in Eastern Africa. As you can see, before they were greater than 400 milliseconds for their round trip time delay, but with the placement of these cables, we see that their round trip time delay has decreased to less than 400 milliseconds. These cables were placed right before the 2011 World Cup in South Africa in order for commentators as well as media could broadcast from Africa to the rest of the world for the World Cup. More than a dozen sub-Saharan countries have mostly abandoned satellite internet since then and are currently using these terrestrial links.
So internet performance in Africa is improving, but it still lags the rest of the world. Packet loss remains higher than in any other region except Central Asia. Loss rates have begun to drop, but many connections can or may soon support real-time communication services, such as video streaming and voice over IP. So UUCP is the Unix to Unix copy protocol. This protocol has 2 main processes, UUCP process, which is for users, and UUX process, which is for mail and news. So TCP and IP are not feasible for countries where electricity is turned off at night, which was the case in some African countries. UUCP can use several different types of physical connections and link layer protocols, but was most commonly used over dial-up connections. However, it's rarely used over dial-up links today. It's occasionally used over TCP and IP.
Migrating from analog to digital broadcasting always offers more opportunities to increase internet access by freeing up unused spectrum. However, this opportunity is not yet being grasped. It's been said that by June 2014, only 19 countries in Africa had started their digital transition. Another transition that Africa is not implementing fast enough is that to the new internet addressing protocol of IPv6. IPv6 is necessary for long-term internet expansion, especially as the Internet of Things becomes a reality.
Traditionally, IPv4 refers to IP addresses being defined using 32 binary digits arranged in 4 groups of 8, essentially an octet, which total number of addresses available was over 4 billion. Having only 4 billion IP addresses would not have been enough to address addresses to uniquely identify all the things that need to be connected in the world nowadays. Therefore, the new IPv6 protocol was developed using 128 bits or 16 octets that are capable of uniquely specifying 340 trillion addresses. This being said, Cisco estimates that by the year 2020, there will be 46 billion things that are connected to the internet. IPv6 allows for this growth to take place several times over. Most new gadgets are of the IPv6 forms, and therefore Governments and companies in Africa need to invest in skills that allow them to transition over to IPv6. They should also keep in mind that service levels for IPv4 may degrade and eventually become unavailable.
One of the protocols that we looked into that we haven't really explored within MSCI 445 is the USSD protocol, which is short for Unstructured Supplementary Service Data. So this is a very powerful protocol for the African market since it is available on every phone and it doesn't require you to download an application. It can be just accessed straight from the network. Many different companies are picking up on this protocol and building applications for banking, utility management, and applications. So how this protocol works is that a user would dial the USSD code that's offered by the application. Then that phone will be able to connect to the network, and then the network will pass it on into the developer's computer and send back response over the internet. This internet will then carry the response back to the mobile operator's computer and then send it back over the network, and then it'll be able to access the calls from the individual's phone. So a real-world case of this being used right now is that, for example, for African women, they can use their phones to track and do some family planning, giving this app called Clue. But over the USSD protocol, they're able to send a code, and then this will sort of predict their current cycle and prevent them from, will help them with their family planning.
There have been substantial improvements in the affordability of broadband services since 2012, but services remain too expensive for many people in developing countries such as Africa. The Connect 2020 agenda calls for telecommunications to be 40% more affordable worldwide in 2020 than in 2012. Considerable work is now underway to improve the conditions that currently mean users in Africa pay up to 40 times more for internet access than their peers in developed countries. One example is the establishment of Internet Exchange Points, or IXPs, at the local level. Africa now has more than 30 IXPs and is well on its way to achieving the goal of at least one IXP per country. Next, we move on to looking at what Facebook and Internet.org has done for telecommunication networks in developing countries. So they're tackling various issues, given that 80% of the world has access to cellular network, but for the remaining 20%, the issue is a lack of basic network infrastructure. Facebook is investing money to develop new technologies to deliver infrastructure solutions. They have specifically developed a connectivity lab that is using unmanned aerial vehicles, or drones, to carry wireless signals to remote areas. The constraints associated with these projects include airspace regulations, low signal strength at certain altitudes, and high costs. The Connectivity Lab is developing other forms of area connectivity technologies such as satellites and radios. The major benefit to aerial connectivity is the relative ease of deployment compared to cellular towers. Internet.org and the Connectivity Labs are getting extra help using specialized aircraft companies as well as talent from NASA's Jet Propulsion Lab. The team's approach is based on the principle that different sized communities need different solutions. They are looking into creating new delivery platforms such as planes and satellites to provide connectivity for communities with different population densities. For instance, in suburban areas that are in limited geographical regions, they use solar-powered high-altitude, long-endurance aircrafts, also known as HAIL, that can stay aloft for months, be quickly deployed, and deliver reliable internet connections. For low-density areas, low Earth orbit and geosynchronous satellites can beam internet access directly into the ground. They also are looking into using free space optical communication, also known as FSO, as a way of using light to transmit data through space using invisible infrared laser beams. FSO boosts the speed of the internet connections provided by satellites and drones, hence making their job easier.
Given the current status and what is being done currently in development within Africa in regards to telecommunications, one of our recommendations would be to make countries such as those in the sub-Saharan Africa less reliant on external expertise by promoting education in telecommunications. So most national ICT policies and strategies mention capacity building as a priority. However, most countries fall short on implementation. And this translates into significant capacity gaps, especially at the level of specialists able to build and maintain infrastructure and services. This makes Africa overly reliant on external expertise. So, Africa needs a coherent strategy for capacity development at all levels, and this strategy needs to look first at ICTs as a discipline, and secondly, as a cross cutting enabler of other disciplines. Secondly, Africa should look to promote internet infrastructure resilience through internet exchange points, also known as IXPs, and also by expanding traditional cable networks as well as embracing sort of leapfrog technologies such as Wi-Fi or low Earth orbit satellites and mobile phones. And then providers will be able to deliver affordable broadband access to even the most remote corners of the continent. Thirdly, it's important that they establish baseline security. Since the networks that are currently implemented are very new, most have been placed in less than 10 years ago. So these network operators and service providers should implement essential routing and domain name system security measures in order to prevent risk and any attacks from external forces. Also, it is important for Africa to loosen regulations, and with this, countries that regulate entry by internet service providers have fewer internet hosts and users, but while countries that regulate internet pricing have higher prices for internet access. Therefore, if they regulate it, the cost of pricing would lower, and therefore more people could have the opportunity to access the internet. And lastly, coordinate and manage internet growth and development. As Africa's infrastructure and user base grows, the need to coordinate and manage internet growth and development becomes increasingly important in order to stay current and up to date on the current technologies. And this concludes our presentation on telecommunications within Africa. Here we have listed all the references we've used within our presentation. Now we would like to open up the conversation and have you ask us any questions. Thank you.